Hello, I'm Adam Biblawi and I'll be explaining to you mechanics. Vectors and scalars is a simple topic. Vectors on one hand have direction and magnitude, while scalars on the other only have magnitude. Velocity is a vector quantity, which means an object's velocity can be 7 meters per second or negative 7 meters per second, due to vector quantities having both magnitude and direction. What is acceleration? Acceleration is a vector quantity. To calculate acceleration, we must do total velocity minus initial velocity, which will grant us change in velocity. Then we must take that change in velocity and divide it by the total time of the equation, and then that will grant us acceleration. But what is acceleration? Acceleration is how fast an object increases its velocity per second. Free fall within Earth's atmosphere has an acceleration of 10 meters per second. This acceleration is due to Earth's mass. If an object has a larger mass than Earth, then it will have a higher acceleration than Earth. And if it has a lower mass than Earth, it will have a lower acceleration than Earth. Momentum is calculated in a very simple way, which is P equals m times v. P representing momentum, m representing mass, v representing velocity. So let's give you a real-life example. If an object has a mass of 5 and a velocity of 10 meters per second and 5 kilograms, then we would multiply 5 times 10, which would give us 50, but not just 50. 50 kilograms meters per second, as these were the units of measure we used. However, if either the mass or the volume or the velocity is 0, then the momentum would also be 0, as mass and velocity are multiplied by each other. Density is the measure of how much mass occupies a certain amount of volume. So in this example, I have given two objects, a balloon which appears bigger than a rock. However, its volume may be bigger, but its mass is smaller. So if we apply the equation of density, P equals m divided by v, P representing density, m representing mass, and v representing volume, then we will find that the density of the rock is actually greater than that of the balloon. This is due to the rock having more mass compacted into it in a less amount of area, rather than the balloon having less mass separated into a larger area. Pressure is the force applied to an object in a certain area. We can calculate the pressure of that using the equation P equals F divided by A. We can also shift around this equation to fit what is given and what is not given. For an example, we can multiply the A to the other side, causing it to be P equals A, P times A equals F, to suit the givens of the equation. Forces can be summed up into Newton's 3 laws. Newton's first law, the law of inertia, states that an object in rest will remain at rest and an object in motion will remain in motion as long as no unbalanced or external force acts upon it. Newton's second law states that an object's motion depends on two things: the mass of the object and the net forces acting or applied to the object. Newton's third law, the law of action-reaction, states that any object that exerts a force upon another object will have that same force reflecting upon it, hence acting upon it as well.
Good morning, guys. Our topic today is work, energy, power. We have two types of mechanical energy, which are mechanic and potential, both measured in joules. This equation is for kinetic and this for potential. We have a couple of equations here. Work equals force times distance, and power is the rate of doing work over time. Efficiency is the useful power output over the total input. We have two types of collisions: elastic and inelastic. Elastic, momentum and energy unconserved, so energy before equals the energy after. And inelastic, momentum is only the one conserved, energy is not, so energy before is not equal to energy after. That's it for today, guys. Thank you.
Today our lesson is going to be about heat. Let's start with a fun experiment. Expansion is where heat makes molecules move faster, so they take up more space, and therefore expansion occurs. Solids expand less than liquids, less than gases. When I ignite this match and heat up the balloon, they will expand. Moving on, we have gas laws. Boyle's law proves that at a constant temperature, pressure and volume have an indirect relationship, whereas Charles' law proves that at a constant pressure, volume and temperature have a direct relationship. Finally, we have the pressure law, where it proves that when the constant volume is present, pressure and temperature have a direct relationship. Next, we have measuring heat, which is measured in joules. The specific heat capacity of a substance is the energy needed to rise 1 kilogram of this substance by 1 degree Celsius. The energy needed equals the specific heat capacity multiplied by the mass multiplied with the change in temperature. The latent heat of a substance is the heat energy required in a specific phase change of this substance. The energy needed for phase change equals the mass times the latent heat. Thermometers. We have two types of thermometers. This is the mercury thermometer. It expands evenly and is a good thermal conductor, but it freezes in lower temperatures and it's poisonous. And it's commonly used worldwide more than alcohol thermometers. As for the alcohol thermometers, they are used in very low temperatures and expand 6 times greater than mercury. Unfortunately, they boil at lower temperatures than mercury, making them unable to be used in hot areas. To convert from Celsius to Kelvin, we add 273 to the Celsius value. The absolute zero is the temperature of 0 Kelvin or negative 273 degrees Celsius, where the particles lose all their kinetic energy, making no motion and no heat in absolute zero. The 3 types of heat transmission is conduction, convection, and radiation. First, we have conduction, where heat is transmitted through contact. Metals are good thermal conductors, while air and most liquids are poor thermal conductors, making them good thermal insulators. As for convection, it is heat transfer due to the movement of molecules within fluids. Cold particles, which are more dense, drop to the bottom of the beaker, while hot particles, which are less dense, rise to the surface. The process of boiling involves convection. In radiation, heat is transmitted in the form of waves through vacuum or material medium. Dull black surfaces are good absorbers and good radiators, while bright and shiny surfaces are poor absorbers and poor radiators. The vacuum flask reduces heat loss through the silvering, which reduces heat loss by radiation, and the vacuum, which reduces heat loss by convection and conduction.
Thank you.
Thank you.
Hi class, today we'll be talking about circuits. Circuits are composed of electrical components that allow the flow of current. These components include a cell, which is the power supply, like these batteries, a load which converts electrical energy to any other form, like this light bulb, conducting wires, and a switch, which allows the completion or the closing of a circuit. The conventional circuit theory states that the current flows out of the positive terminal through the circuit and into the negative terminal, while in reality it's the opposite. The main properties of circuits include voltage, current, and resistance. The voltage is the amount of energy per unit charge. It's measured using voltmeters and the unit is volts. In series circuits, the voltage can be calculated by multiplying the current with a resistance to find the voltage in a certain point, while in parallel circuits the voltage is all the same. Current is the amount of charge flowing per time. The unit is amperes and is measured using ammeters. In series circuits, the current is all the same, while in parallel you need to divide the voltage with a specific resistance to get the current in a certain point. The resistance, the unit being ohms, is a measure of how a conductor resists the flow of current. In series circuits, to calculate the resistance, you can just add all the resistance values together, while in parallel circuits, you need to add the reciprocals of these resistance values. For example, if this resistance is 8 ohms, you need to add 1 over 8. Temperature, length, and cross-sectional area are factors that affect resistance. To identify power or calculate power, you need to multiply voltage with current. If you know the power and the time, you can calculate energy by dividing them, which is measured in joules or kilojoules. If you divide the power with a larger unit of time, like hours, the energy will be measured in watt hours or kilowatt hours. A device's efficiency is its useful output energy over its total input energy times 100. To find the price of energy, you multiply the energy in watt hours or kilowatt hours by the price per watt hour or kilowatt hour. This sums up electricity or circuits for grade 10. Thank you. Hey class, today we'll be talking about magnetism. Every magnet has a north and south pole. North and south poles of different magnets attract or stick to each other, and the opposite. The same poles from different magnets repel, because the magnetic fields of different poles move in the direction of each other, allowing them to stick or attract, while the magnetic fields of the same poles move in opposite directions, preventing them from sticking and making it very hard for them to attract. This sums up magnetism for grade 10. Thank you very much.
Good morning, guys. Our topic today is going to be waves. This is the shape of a wave. Those are crests, those are troughs, amplitudes, and wavelength. Period is time taken for one complete wave. Frequency is number of waves per second. We have a couple of equations here. T, our time, equals 1 over frequency, and time and frequency are inversely proportional. Velocity equals frequency times wavelength, or wavelength over time. We have two types of waves, transverse and longitudinal. Transverse, energy particles in the wave vibrate perpendicularly to the wave, direction of the wave, like water waves. Longitudinal, energy particles vibrate parallel to the direction of the wave, like sound waves. We have four properties of waves: reflection, refraction, diffraction, and interference. Diffraction, waves face an obstacle and then they bend together to try to pass that obstacle. To a reflection, that's an incident ray, and that's a reflected ray. We have something called the critical angle when an incident ray and then the reflected ray is equal to the normal ray, so it's like that. The total internal reflection when the incident ray or the reflected ray passes the critical angle, so it does like this. Where the interference when two waves opposite each other, and the result is a net effect between them. And the refraction is like this. That's an example for it. As you can see, the pencil is showed that it's broken. However, it's not broken. Only light passes through it. Light passes through it slower, as water is a heavier medium than air. Thank you guys, and see you next class.